So our objective, oh, why do I always end in a different color? Our objective is to understand a normal distribution so that's the key thing. And then we're also going to, let's see, how do I want to say this? Apply a set of data to a normal distribution to determine percents in various categories. So that sounds really weird, but we'll get in. You'll understand what I mean when we get there. It's kind of like most of our standards. When you start doing it, you go, oh, that's what that means. So this is the lesson 13.5. And so let's talk about first, what is a normal distribution? So our book describes it as a bell-shaped, so that's why you hear this word bell-shaped curve, bell-shaped symmetric distribution. With the center being the mean of the data. So in other words, if things are spread equally to the left and to the right of the mean, that's considered normal. Now some people may say, well, what if the mean out of 100 was 12? They would still consider it a normal distribution. Okay, welcome to college, where out of 100, 12 is the mean. You have these outliers of the people that get the 100, but you got a ton of people who get down real low. So that's in college where they'll grade on a curve. And what they'll do is they'll make 12 the normal, the C, basically, and then they'll kind of go out from there. Figure out who got the A, B's, A's, C's, D's, F's, okay? So, how do they do that? I got to go to the next slide because I got to draw a picture. Everybody ready for the next slide? Okay. So, let's draw a picture of what would be considered a normal distribution. Or actually, let's go back here and let's add some things. So, you're going to hear normal distribution, and you're also going to hear normal curve. Okay? So, this is some key things about it. 68% of data falls within one standard deviation of the mean. Now, when we say 68%, we're saying one standard deviation to the right of the mean, one standard deviation to the left of the mean. So it's a complete section of two standard deviations altogether, okay? So to the right, to the left, one standard deviation. This is why we figure out standard deviations, so we can figure out where that 68% of the score should be, okay? Then you've got 95% of data, bless you, falls within two standard deviations of the mean. So that should say within for the 68%. So if I go 2 to the right, 2 to the left, so a total of 4 standard deviations, 95% of all scores should be in that range, okay? And then you would think the last number would be 100, but it's not, because there's always little things. So we've got 99.7% of data falls within 3 standard deviations of the mean. I'm going to clear up that 3. That looks lousy. Okay. So notice that there's 0.3 unaccounted for. They're beyond. It's the 3rd standard deviation. 3 to the left, 3 to the right. Okay, now I want to draw a picture so you can see what this looks like. Are we ready? Can we go? Yes. Okay. Now, I'm going to do my best, and I'm going to be lousy because I just know how I draw. That's not too bad. Pretend this is absolutely symmetrical. He's a little demented looking, but that's okay. Yep. Let's try that again. Oh well. That's as good as I'm going to be today. That's our mean. That would be dead center of our bell-shaped curve. That's why they call it a bell-shaped curve. Okay? I forgot what color did I use next. Purple. Okay. I'm going to keep it the same. So what it said is if you go 1 standard deviation. Do you guys remember what the symbol was? Kind of looked like a little cherry bomb. A little circle with a tail around it. I won't do that. I'm just going to write SD for standard deviation. Okay. So 1 standard deviation to the right of the mean, 1 standard deviation to the left of the mean. According to our information, that should be 34% each, which gives us the total we wrote on the other page of being 68%. Okay? Green. Okay, the next. Okay, this would be now a second. So from here to here is 2 standard deviations. Here to here, 2 standard deviations. So all I'm doing is going 1 more standard deviation to the right, 1 more standard deviation to the left. Now again, my picture, I'm going to clear up this one a little bit, make him a little bit further. Okay. And for each one of these, they represent 13.5%. So a total, let me go back to the purple. This represents 68%. And for the green, so from green edge to green edge, there's your 95%. And I think I used orange. So from the center to here is 3 standard deviations. Let me continue that mean line down a little bit so you can see. It's 3 standard deviations. And because this is so small, I'm going to have to put the number here. So this is 2.35%. This is 2.35% of the data is there, for a grand total of 99.7%. Goes from here to here. Okay? Just clarify here. He goes here to here. Okay? Now we have little trickle guys off to the ends. So I'll just put them in the red. These little bits here are 0.15% and 0.15%. Okay. Now, life doesn't always work out beautifully, perfectly, but this is a traditional how things fall. Okay. So how is that going to help us? Okay. So what I want to do is go through an example, and basically, can I move? Are we good? Everybody good? Okay. So basically, I'm going to give you this scenario. Let's say that there is a test that had a mean that was equal to 74, so that's standard average, and there was a standard deviation that was equal to 8. Okay? So, let's answer some questions. What's the percent of students whose score is no more than 90? Okay, so what do? I've got to figure, let's see, and we don't have any idea. We just want to know percents. So let's do 74. If I add 1 standard deviation to it, I get to 82. If I add another standard deviation to that 82, now I get up to the 90 number. Okay, so I've got the left side from the mean, that all of those kids are in that category, and then I've got to the right side 2 standard deviations worth. Okay, so let's think about it. So from the left to the mean, if we go back and look at our bell-shaped curve, from the left, 0.15, 2.35, 13.5, 34. All of that is to the left of the mean. Okay, so let's write that in. So that would be 0.15%, 2.35%, 13.5%, 34%. Now, when I add 1 standard deviation to the right of the mean, I've gone another 34%. And when I go 1 more standard deviation, how much more have I gone to the right? What's that next percent? That's at 13.5. Okay, if I add all of those up, I get a grand total of 97.5%. Now, the other option would be to say, okay, what I didn't cover was the 2.35 and the 0.15. Add those together, subtract them from 100, bam, I've got my answer, right? Wait a second, that's not that. So that would be a different way of finding that answer. Okay, let's try a different question. The percent of students scoring between 58 and 74. Okay, so 74 is my mean. So now what I'm going to do to get to 58, I'm going to have to subtract standard deviations. So 74 take away 8 is going to give me 66. And if I subtract 8 from that, that will give me the 58. So students who score 2 standard deviations to the left represent these percents. So the first one is 34%. The second one is the 13.5%. for a grand total of 47.5%. Patrick?
Where'd you get the 8 from again?
That was given, remember standard deviation at the top? It was 8. So we're only using, the only numbers we can use, because the only numbers they gave us, was that we have a mean of 74 and a standard deviation of 8. The other numbers are what we know has to be true about a normal curve. Ian?
On like a test or anything, would we ever have to get the standard deviation before we started doing this?
No, I won't do that on this type of question at all. Will you be asked to do standard deviation on the test? Yes. Probably once. Okay? All right, let's try just a couple more questions. Same scenario. We're not changing the given information. Let's try the percent of students who score at least 74. So at least means 74 or what? Less or more? More. So they could score from 74 to 100. So we're basically looking at our curve, and we just are interested in this portion of it. So without even needing to calculate, what should the answer be on this one?
50%.
50%. It's half of the entire curve, right? So we could just look at that and see that it would be 50% of the students. Okay? Because it's the right half of that. All right, let's try another one. Now, we could put in here, if you don't believe me, this would be the 34% plus the 13.5% plus the 2.35% plus the 0.15%. But it's far easier just to be intelligent enough to say, hey, that's half the curve. Oh, half of 100 is 50%, okay? Okay, and let's try a different one. Ooh. The percent, oops. Of students scoring less than 66. Okay. So if we think about that, we have our standard deviation. So we have our 74. To go left would be subtracting, and if I subtract it from there, I get 66. So I've taken out the 34% for the first standard deviation. So I'm from standard deviation 2 all the way to the left. So that gives me the 13.5%, the 2.35%, the 0.15%. And what does that total up to? What is it?
16.
It would be exactly 16%. Okay? Let's see. Yes? Absolutely. That's the whole point to today, is understanding how much does one standard deviation represent? How much does 2 standard deviations represent? How much does 3 standard deviations represent? What's left over? So you've got 4 numbers, but here's the beautiful thing. That's all you have to memorize, because they're the same 4 numbers to the right and to the left of the mean. So that's the key that you got to know. 34, 13.5, 2.35, 0.15, bam. Okay? And then what you do is you play with your numbers, the mean and the standard deviation, to find the numbers that are in the problem, to let you know where in that graph are you. Okay? So what might be helpful is to draw yourself a picture of the diagram and put in the marks for first standard deviation, second standard deviation, third standard deviation, what's left over, and then literally put your hand down where the numbers are that you calculate. Oh, it's from here to here. Oh, that covered 34 and 34, 68%, I got that. Okay, oh, it's from here to here. Okay, that's second, third, and leftovers. Okay, so 13.5, oh, okay, I got it now. Or you could go, ooh, okay, the leftovers, 34 I didn't count, so 50 take away 34, 16. Bam, I got the answer that way. So there's multiple ways to get that answer, but that might be a better ways to look at that graph, visualize it, have it, and then just kind of use your hand to do the cutoff points. You have to do slight calculations to figure out where those cutoff points are. Amanda?
On the test, could we like make a diagram to like help us?
Yes, okay. Here I am as a student taking a test. If there's any formulas I need to know, like how do I calculate an outlier, I write it at the top of my test before I begin. Because in the throw of the test, I sometimes get nervous and I forget things. I draw pictures of those numbers, that's bell curve, I put that up there. That's the first thing I do is write down anything that I think I might be needing, or I might write down the steps it takes to do standard deviation, I write that at the top of my test. And then I've got everything I need when I'm ready for that question, okay? All right, I'm gonna pause right now.